Next, we're going to try and look for the 16S RNA gene sequence for an extremophile. So I've come to NCBI, so you know very well how to find NCBI. And I've already put it to nucleotide because that's precisely what I'm looking for. Then I'm going to put in the name of an extremophile, so you can get your research done in Google or wherever else you want to get your data from. And then now you can use that to find the names of some extremophiles that you might be interested in. Ideally, you should just come straight to NCBI and instead look in all databases or in PubMed or PubMed Central, and that will give you papers. And then you say, I want a cyanobacteria, extremophile, or extremophilic cyanobacteria, or extremophilic fungus. That's where you should be doing your work. That way you get proper data. But in the beginning, you can start with Google just to get the names of some different extremophiles. So I've put this in, and then I've hit search. And as I've done that, what I got here was some hits. And you can see that there's quite a few of them, right? So how do I determine what I'm looking for? If we look carefully, we can see that this one, it already tells you it's a circular bit of DNA. That means it's the entire genome, right? And over here, this is a partial bit of DNA. We're not looking for partial sequences as such. What we want is something in the ballpark of our 16S gene. And remember from the paper, we know that the 16S gene is around 1,500 base pairs big. So this one looks like it fits because it's 1,000, almost 1,500 base pairs. So I'll say thank you very much for this one. And I can either click faster, and you know how to do these things. But for now, I'll just send it to the clipboard because I want to collect one or two. Yeah. Then I'll look for another one. So let's say what do you want? E. coli. So let's look for that one. And what I've got in here, again, the same story. So now I know what I'm looking for. This is too small. This looks like the right ballpark. So I'll get that one, thank you. And it's saying, although this doesn't, well, we don't know what that really means. Let's look for one which is completely obvious. There you go, this one's a partial sequence. Partial sequence. Well, you can go through till you find exactly what you're looking for. But for now, I'll go with this one. Although this could be the name of an actual gene, rRNA, because this is the gene, this is the nomenclature for a gene. That's why I'm avoiding it. So in actual fact, I'll just say, let me get this one, just for the sake of this example. But you can look through. You can keep on going through here till you find one which is complete. So I will send that to the clipboard as well. And then once it's sent, I will go to my clipboard items. So I just see the two of them, because there are two that I've put there. And then let's move this over here. So here are the two that I chose. I want to view the FASTA. And I've got my FASTA now. So here are the two FASTA sequences. And now I can download them. So I can click them both again. And I can export both of them to the file. Download FASTA format, blah, blah. I download that. And there it is. I'm going to call it my 16S rRNA experiment 1. That's what I'll call it. Yeah. Okay. Now I'm going to go to Ugene. So remember I told you that you need to get a software. So Ugene is free, you can download it. And that's the one I'm using. So I'm going to open the file that I've actually downloaded. I can open them as separate sequences, or I can merge them into a single sequence, depending on the things that you're doing. In this case, we want them as separate ones. And I can also put them into an alignment. So I can also do that, which is really useful for phylogeny studies. But for now, I'll just do that, so it will see them individually. So here are the two sequences. There's one, there's the other one, and you can play with these things so that you can see each one individually. You can just check here for the things that you want to do. You can circularize them like that. So if it was a plasmid, that's what you would do. Or you can have it as a linear one. So now it's just appearing as just a line of DNA. And it basically goes all the way from the beginning all the way to the end. That's what you're looking for. So if you're able to import into Ugene, this is a tool that can allow you to do restriction analysis and cloning, virtual PCR, a whole bunch of stuff. And we'll use it as we go. But for now, I just want you to be able to import a sequence and open it and see it in here. And then I will show you how to use it for doing a multiple analysis. Once you've done a multiple analysis, that will allow you to generate a tree, your phylogenetic tree.